So we have our next topic, the summation of in-phase sinusoidal waves. So when we say in-phase, it is at the case 1 which has a 0 degree. Okay? Walang value yung phi, angle phase. So when two or more sinusoidal voltage or current waves are in phase and have the same frequency, they may be added to yield a sine wave for the same frequency. The resultant wave will then have a maximum value that is equal to the arithmetical sum of the maximum values of the component waves. Since they are in phase, yung dalawang, for example, dalawa or tatlong vectors mo, they are in phase. So all you have to do is add them arithmetically. So we have E maximum resultant is equal to E maximum 1. The first wave, sine wave, E maximum 2 plus E maximum 3, and so on and so forth. So for the maximum current resultant naman, ganun din. IM1 plus IM2 plus IM3, and so on and so forth. Ganun din yung power kung pare-parehong in phase. So these equations may be expressed in terms of root mean square or effective value or RMS by dividing both sides either 1 by square root of 2. Kung gusto mo namang kunin yung mga RMS values neto, your E maximum resultant, you just divide it by square root of 2. Ganon din yung I maximum resultant. So for example, we have 3 resistors having ohmic values that are respectively 9, 12.5, and 16 ohms are connected in series to a sinusoidal source of EMF whose effective voltage is 120. Calculate the current through the circuit and the voltage drop across the individual resistors. So yung mga given na 9, 12.5, and 16 ohms are already ineffective or RMS kasi they are not, hindi sinabi sa problem na maximum values tong mga to. So in phase, diba, we have a sine wave that starts 0 at t is equal to 0. So for example, this is our first wave. This is E1 is equal to E1M or EM1 sine theta. So this is another wave. E2 is equal to EM2 sine theta. Third wave, E3 is equal to EM3 sine theta. So pag pinagsama-sama natin to sa iisang x and y axis, example, ito si E1, tapos ito yung E2, and this one is your E3. So as you can see, they are in the same phase. So lahat ng values ng EM1 mo, EM2, and EM3, EM resultant, kung gusto mong kunin yung E maximum resultant, it is just the arithmetic sum of the EM1 plus EM2 plus EM3. Or kung gusto mong kunin yung values ng E resultant, add the values here. Pag nasolve mo na yan, may masasolve kang E1, E2, and E3. So the resultant will be E1 plus E2 plus E3. So, ganyan lang yan. And usually, in-phase voltages and currents occur in a resistive load. So, resistive. So, ano yung mga resistive loads? Ito yung mga ilaw. Okay? Yung mga lamp natin sa bahay, resistive yung mga yon. So, they have a unity or 0 degrees. So, in our problem, 3 resistors, they are connected to an AC supply or AC source. So, resistive resistor, ito yung symbol niya. This is, let's say, R1, R2, and R3. They have the same frequencies, and they are connected to a source equal to 120 volts. R1 is 9 ohms, 12.5, and 16 ohms. Calculate the voltage drop and the total current. So, basic Ohm's law. What is the value of your total current? So, simply, we first solve the total resistance R1 plus R2 plus R3. We'll get 9 plus 12.5 plus 16. So, that is equal to 37.5 ohms. So, total current will be 120 divided by 37.5. You have 3.2 amperes. Solving the voltage drop across each resistors. So, ano yung mga drops sa resistor 1, resistor 2, and resistor 3? So, for resistor 1, we will denote it as V1. Voltage drop, it is just Ohm's law, I1, R1. V2, I2, R2. V3 is I3, I3. So, as you can see, the current flowing in R1, R2, and R3 is the same current sa total na nasolve natin. So, I1, I2, and I3 is equal to 3.2. 3.2 multiplied by R1, 9. 3.2 multiplied by 12.5 and 3.2 multiplied by 16. That is 28.8. 40 volts and 51.2 volts. So, pag resistive, pure resistance ang given, so you can just solve gaya nung sa DC circuit kasi wala pa namang reactances. Okay? So, number 2, 4 incandescent lamps, resistors, having ratings of 50, 60, and 75 and 100 watts respectively are connected in parallel and to a sinusoidal EMF whose effective voltage is 120 volts. Calculate the current through each lamp and the total current. So, number 2, we have 4 incandescent lamps. So incandescent lamps are resistive loads. They are connected in parallel. Let's say this is A, B, C, and D. And it is connected to 120. This is the symbol for AC source. So we will calculate the current through each lamp. What will be your IA, IB, IC, and ID. And the total current. So here, ito yung total current natin, IT. So may mga wattages yung mga lamps natin. For A is 50 watts, B 60 watts, C 75 watts, and D is 100 watts. We can solve IA, IB, and IC, and ID. Remember, the voltage across any parallel is equal to the voltage source. So, dun sa DC nyo, the voltage source is equal to the voltage drop if it is connected in parallel. B1, B2, B3, B4. Voltage drop here, dito, tsaka dito, and dyan. It is equal to the source voltage 120 volts. So may voltage tayo, may power tayo. We can use the formula P is equal to EI. So solve natin yung IA equal to P over E. This is PA for lamp A. So 50 divided by 120. For IB naman, 60 divided by 120. IC is 75 divided by 120, and ID is 100 divided by 120. This is 0.417 amperes. 0.5 amperes. 0.625 amperes, and 0.833 ampere. Total current will just be the sum of currents IA, IB, IC, and ID. Basic DC circuit. So, total current IA plus IB plus IC plus ID. Equal to 2.375 amperes. Next, number 3. The in-phase sinusoidal currents in parallel branches of a circuit have the following equations. So, I1 is 17 sine 3770. I2, 22.6 sine 370. So, as you can see, the frequency are the same. 2 pi f, same sila. And we are going to solve the sinusoidal current. Write the equation for the summation of the resultant of the two waves. Calculate the effective currents in the individual branches and the resultant current. So we have two waves, I1 and I2, and they are connected in parallel. So may load tayo na since this is in phase, they have the same frequency. So it is just a resistive load. Yung I1 natin dito ay may equation na 17 sine 3770 and our instantaneous current here is 22.6 sine 3770. Write the equation for the summation of the resultant. So ano yung equation ng total current natin? What will be your IT, small IT equation? Calculate the effective currents in the individual branches and the resultant. So yung una muna, letter A. Letter A, we have IT is equal to I maximum resultant sine of 370. So IM resultant will just be the sum of IM1 plus IM2 equal to 17 plus 22.6. So that is equal to 39.6 amperes. Our equation now will be equal to I total is equal to 39.6 sine of 370. If we are going to graph or draw the vector diagram or sign, sige, yung dalawa, i-draw natin. For the sine wave, yung isa ay 17, yung isa ang maximum niya ay 22.6. So, let's say this is your 17. Ito yung 22.6. Nandito. Let's say nandyan. They are in phase. Yan. 22.6. So, nasan yung 39.6? So, it is the resultant of I1 and I2. So, let's say nandito na lang. 39.6. Assume natin na dyan. So, ito yung resultant IT. Paano pag vector? So, let's say this is your reference. Ito yung reference natin na x-axis. Ito yung I1 natin. Na 17. I2 na 22.6 and the resultant of these two is dito. So, ito yung IT, I1, and I2. Ito yung equation ng na-answer natin sa letter A. Letter B, calculate the effective currents in the individual. So, effective, it is just the ERMS is equal to EM all over square root of 2. Or I, RMS, IM divided by square root of 2. For the first current, I1, we have maximum current equal to 17. So, IRMS1 is equal to 17 divided by square root of 2. Next, IRMS2 is equal to 22.6 divided by square root of 2. And the resultant RMS of this, so let's say IT na lang. IT will be equal to the sum of IRMS1 and IRMS2, or 39.6 divided by square root of 2, or IRMS1 plus IRMS2. So that is equal to 39.6 divided by 28 amperes. So IRMS1 is equal to 12.02 and 15.98. So if you add IRMS1 and IRMS2, it will be equal to 28 amperes.